All right, now let's look at the logon view for the account controller. This is a bit more complex than the index view because what's happening here is it's accepting user input for authenticating the user. It uses a regular HTML form, but using an HTML helper to build the structure. So this is going to create the opening form element. Now it's important to notice here that this page includes no ASP.NET Server controls. The page uses HTML elements and JavaScript only. So again, you have much more control over the HTML within the page. Here's the meat of the form. So we have a legend with account information, and then we have a label, and it's going to display the name of that field. So it's going to prompt for the username. So it's associated with this text box, and this HTML.textbox4 uses the information, this is a lambda expression, to grab the information from the username field within the model that is passed to the application. Conversely, when the user enters their username here within the text box, that's going to write that username value into this field within the model. And so it prompts for the password as well as provides a checkbox for allowing the user to remember them. And then it has a submit button that allows the user to submit their login credentials. It also has a validation summary helper up here that if there's any problems, if it can't find the username generally or if it's invalid in some way, it's going to provide an error message at the top of the form that says login was unsuccessful. Please correct the errors and try again. All right, I'm going to run the application one more time. And go to the login page and look at the page source. So here's the HTML that was generated for that page. And here's the actual form. Notice that it rendered into this form with an action going to post back to itself using the post method. And then here is the div tag and the label for the username associated with this field. And it's implemented as an input field with both ID and name set to username, type of text, and empty value. And it would populate that value. If this was a second attempt, it would repopulate that username field for the user. As you can see, you have a lot of control over the HTML, and it's very clean HTML because the view itself defined very clean HTML. Now this particular page is bound to a model. So I'll stop the application and scroll back up here. I'll move that a bit. And here is how MVC binds the page to a particular model. It inherits from the system.web.mvc.view page, and it's using the logon model class. So this is what's known as a strongly typed view. And it allows you to do things like write these lambda expressions to reference the values within that model object. Now let's talk about those models. The model part of an MVC application, over here within the models folder, encapsulates the data, including state, and the business rules of the application. The interesting thing about models in MVC applications is that you can implement them just about any way you like. There are far fewer restrictions, far fewer conventions for models than the other parts of an MVC application. So you can use custom objects, entity framework, link to SQL, and Hibernate, or any combination of techniques within a single application. The fundamental requirement is that the model needs to provide data to the controller and the view when necessary, as well as take care of storing and updating data while keeping it valid. Assuming, of course, that those are part of the application requirements. Now, if we go back and look at the index view of the home controller, notice that it inherits from system.web.mvc.view page. It's not bound to any particular model object. And that's because it doesn't use a model, because it doesn't use any data. It's not creating anything dynamically other than that single string of text, and it's not something that the user can edit. But the thing is that virtually all non-trivial MVC applications are going to have at least one model, and various views will use it in various ways. All right, so this is the file that defines the model controller, and it in turn uses this accountmodels.cs file. Now, the account controller does use a model because it has to have a place to store user login credentials, retrieve them, and perform various maintenance functions. It makes use of the ASP.NET membership provider, as well as that SQL Express database that I pointed out to you in the app data directory. But this is the file that defines the model itself. Now, this is a fairly complex code file, so I'm only going to look at some of the high points. You'll need to understand the ASP.NET membership provider and forms authentication in order to fully understand the code that is going on within this model. Now, from the perspective of the MVC application, and in particular the account controller, the model provides two services: Forms Authentication Service and Membership Service. Now, both of these classes implement interfaces. So you can see the iMembership service and the Account Membership service here that implements that interface. And these do various things like allow the user to log in, and sign out, as well as perform password maintenance. And it provides various properties in order to specify things like the minimum password length. The models region here contains the actual models that are used by the account controller. It contains definitions for change password model, logon model, and register model classes. And the controller uses these to send data to a view and get updates from the view. So this is one example where you can see that you can define multiple models that are used by the application. By the way, it's not necessary to use the word model in the name of these classes. That's just a convenient way to keep it straight when you're looking at the code. But it's not something that MVC itself takes advantage of. So here's the logon model. And notice that it has properties for the username, the password, and the Remember Me option. So this is obviously the object that is behind that logon view. And if we go back over to that view, that's that model that is tightly bound to. So that's how the two are linked together. Finally, there's this validation section down here. This contains some code to validate the user input and provides an isValid method that lets the controller find out if the data is valid. And it provides some formatted error messages as well. So there's a lot of code here. The nice thing is, as I mentioned, you're virtually unlimited in how you implement the models in an MVC application. Most of the time, you'll probably use model classes that really just wrap the data that is stored in a database. But this account model shows one of the many ways that you can also implement various business rules, giving you complete control over how your application interacts with data in whatever data store it resides. All right, so that's the main MVC application. Let's talk now a little bit about testing. As part of creating this application, we created this test application. This is one of the biggest benefits of developing MVC applications. They're far more testable than web forms applications. The page object in a web forms application has far too many dependencies on underlying components, which really makes it hard, if not impossible, to write clean, simple unit tests. So this project contains the infrastructure that you need to write tests for the sample MVC project. The tests that are included are pretty rudimentary, but they show what you can do. So you have different properties, references, and so forth, and you can drill down into controllers. And here are the tests that it implemented for the two different controllers. So I'll open up the home controller test here. And this provides simple test methods for the home controller's action methods, index and about. These tests use a standard testing pattern of arrange, act, and assert. So you first arrange the test by instantiating whatever objects you need for the test. In this case, we need an instance of the index controller, so it instantiates that up and puts it within the controller object. Then the test acts on that object. In this case, it's calling the index method of the home controller here and getting that result. It can then use that result in order to extract the view data and assert something about it. In this case, it's asserting that the return value from this index method invocation is equal to this specific string. And if it is, then it returns true. If it isn't, it returns false, the test fails, and you have to fix something. Assuming that you're running an edition of Visual Studio 2010 that supports testing, you can select Test, Run, All Test and Solution to run the tests. If you haven't modified any parts of the sample application, then that will run all of the tests and they should all pass. And as you can see, they have. But if any failed, you would get information about what tests failed, and then you can take action to fix whatever the problems are.